Okay, so serial dilution. So if I take a stock solution, and say my stock solution has a concentration of 820 parts per million. If I want to make a much more dilute solution of that, I could take a small amount of that and make it into a very large amount, so maybe 1 ml and make it up to a litre. Or instead, I could dilute it and then dilute it again. And that way I'm measuring out larger amounts but using smaller amounts of solvent. So it's more accurate, it's more precise, and it's less wasteful. So in this case, if I take 820 ppm, if I take my solution that has that concentration, and I take 25 milliliters, and then I make up a new solution from that, I make it up to 100 milliliters, and then of that solution I take from that and I take another 10 milliliters, and this time I make it up to 250 milliliters. The question is, what is the concentration of my final solution here? So this all comes back to the fact that C1V1 is equal to C2V2. Concentration by volume has to be equal to the new concentration by the new volume, because concentration by volume is the amount of material in a solution. And when you dilute it, you don't change the amount of stuff that's dissolved in there. So for the first one, we're going to say that our initial concentration is 820 ppm multiplied by 25 milliliters is equal to our new concentration multiplied by 100 milliliters. And of course we can move this down here and we will get 820 ppm by 25 over 100, and the milliliters are going to cancel out, so as long as these units are the same, that's okay. Is going to be equal to our new concentration of this here, and 820 multiplied by 25 divided by 100 is going to give you 205 ppm. And then we can just repeat that again. So if we take 205 ppm, if we take 10 mil of that and make it up to 250 mil, what's our new concentration going to be? Well, 205 multiplied by 10, so that's ppm, 10 mil is equal to 250 milliliters times the new concentration, which we're going to call C3. So 205 by 10 divided by 250 is going to give you an answer of 8.2 ppm. So that's our final answer. If we think about what we've just done, we've made a solution that's 100 times more dilute than this. And if we had wanted to do this in the first place, we would have had to take just 2.5 mil and make it up to 250 mil to make this final amount of solution. And measuring out 2.5 mil is much less precise, or can be much less precise, than measuring out 25 milliliters, particularly when you're using large volumetric glassware. The shortcut to this, well, you don't have to do these out as separate stages. So you can just do them all at once. 820 ppm multiplied by 25 divided by 100 multiplied by 10 divided by 250 is going to give you the same 8.2 ppm. Because you're multiplying and dividing, it doesn't matter what order you do them in, they are commutative. So you'll get the same answer out. So this is the fast way of doing it, but this explains what's actually going on. Okay, if you have any questions, post them below. I hope that was helpful. That's all for now.